Today is April 19th, 2020, and we are showing off ENPM 673 Project 4. This is our Lucas Kanade tracker. In this project, we'll be showing off tracking for a video of Usain Bolt running, a car, and a dragon fighting a baby. So let's go ahead and get into it. We'll just go ahead and hit run. You can do this with any IDE of choice, or you should be able to just run it straight from a Python shell, if you so desire. As you can see here, we have our menu. We'll go ahead and start with Bolt. And then we have the option of entering in a soft target. We have ours listed since we're all using PyCharm, and all of our folders are local. Alright, a new window will pop up. Didn't mean to do that. There we go. This will just show off the image where the template is actually being pulled from, and showing that template there. And right here you can see that we have our template. We're doing a pretty good job tracking. We're going to lose him a little bit here, but our robustness will trigger, and we were able to track him for the rest of it. Let's move on to the second problem, the car problem. Once again, we'll just enter in our local folder. Now the reason that we do this instead of having these as hard targets is, one, each of these has their own little set of parameters that we found best works with this, like number of iterations, turning on a rotation factor, turning on a robustness factor. Each one of these has their own separate values, and we found that changing things up helped us get better results. So once again, we'll hit enter. You can see our frame. This is coming from the 20th frame. And we're going to go ahead and watch it. Now we're going to start losing the car a little bit here, but we do manage to hold on to it. As you can see here, we have managed to track the car from one lane to the next. Now, what you might notice is that that rectangle does not fit the entire car anymore, and this is because we don't actually resize our rectangle. Instead, what we do is we just shift the rectangle to the correct location. Initially, we did try to reshape the rectangle, but ended up causing errors with our mathematics and our algorithm when it came to the Jacobian subtracting out the gradient. And let's go ahead and move on to our third problem. Once again, here's our frame. This one actually comes from the first frame. Lots and lots of fast movement, which is really hard to track. And this is why we actually turned up the number of iterations and set a little bit higher of a threshold. But that is the completion of our project. Hope you enjoyed, and best of luck.